Hello, my name is Mr. Rogers, and you are watching the video lecture for sound. We're on jumping ahead to chapter 2-1, and so this video lesson is all about sound. And so this first page, guys, is our lesson objectives. You do not have to write anything down. But two things we want to accomplish today is to explain how sound travels. We also want to identify factors that affect the speed of sounds. Those are two big ideas we want to get across to you. So let's move right into it, guys. Sound. You guys can hear me sing would be sound. Probably not a good idea. All right. So what is sound? Sound is a disturbance that travels through a medium as a longitudinal wave. And I'm going to stop right there because you're already thinking to yourself, what in the world is a longitudinal wave? When you think longitudinal wave, think about like an accordion file or a spring. It's going to be compressing and expanding, compressing and expanding. So it travels through a medium. That's the other big part there. What in the world is a medium? When we use the word medium here, we mean it has to travel through something, some type of matter. It has to travel through matter. So if that's air molecules, if that's some kind of solid, like a steel pipe, if that's water, it's some type of medium, some type of matter it has to travel through. So sound is a disturbance that travels through a medium, through solids or liquids or gases, some type of matter, as a longitudinal wave. So as that compressing and expanding. So traveling through matter, compressing and expanding, compressing and expanding. And so what this looks like, we're going to jump ahead real quick. If these lines here were like air, even just air particles floating around this tuning fork, we have two parts here where you can see it's kind of expanding and compressing, expanding and compressing. So as that sound, those vibrations, which would be the disturbance, travels away from the tuning fork, it's going to expand and compress the air around it until it reaches your ear. And that's how sound travels. It travels, again, that's that medium would be the air, and that longitudinal wave is that compressing and expanding the air molecules until it reaches your ear. So vibrations cause that medium to move, compress and expand until it reaches your ear. So sound then is made when the air particles are disturbed, and the particles compress and expand away from the disturbed area until they reach your ear. So it's constantly moving the air particles until they reach your ear. So the next part in this, guys, kind of a big fact we think about is sound only travels through a medium. It cannot travel through open space. It has to travel through something. So in the voids of outer space, you know, if something blew up, you wouldn't hear it. There's no air to carry the sound. You would never hear the explosion. So it has to be going through a medium. So moving forward, we talk about how fast speed can go. Like what affects speed of sound? What affects how sound travels? Because sound doesn't travel the same through matter. It travels differently through air. It travels differently through different types of air. It travels differently in water, and it travels differently in solids. So there's a lot of differences in how it travels and how fast it travels. So there's three things you look at to determine how fast speed travels. The first one is called elasticity. And elasticity is the ability of a substance to bounce back after being disturbed. Think of rubber band. Rubber bands bounce back after being disturbed. Think of guitar strings. It has to be wound just right for it to elastic and bend back after you've plucked it. So be able to bounce back, and the better it bounces back, the better it's going to carry sound. So the more elastic it is, the better it's going to be able to carry that sound. Secondly, we have the idea of density. So density is the amount of matter in a given volume, so how much matter is in a space. And actually sound travels slower in denser materials in the same state. So denser air, sound will travel slower through that. Denser steel, it's going to travel slower through that compared to a lighter steel. So it's kind of weird, even though different states of matter have different densities, inside of that state, the denser it is, the slower it goes. So finally here we have temperature. Sound travels slower in colder mediums. So the colder the air, the slower sound's going to go. The warmer the air, the faster sound is going to travel. So to recap real quickly here, guys, we talked about, what is sound? Sound has to travel, first of all, through something. Those vibrations, a disturbance or vibrations, causes the air around it to move, and it compress and expand away until it reaches your ear. So, and then also how we determine the speed of sound, what affects it. The elasticity of the substance, think of that guitar string bouncing back after you pluck it. Density, how much matter is in a given volume. And the denser it is, the slower it's going to go in a given material. Not just, states of matter are different. And then finally, temperature. Slower it is, the colder that medium must be. Alright guys, thank you for watching this short video on what is sound, and we'll see you guys along the way.